Hello, welcome to the second section of this course, which is building blocks of a blogging app. In this video, we will first initialize our app and then learn what are Django models. We will then move on to using migrations and learn why they are important. And finally, we will close this video with learning about the Django ORM. Before you start, make sure that your virtual env is activated and you're inside your project root. This is the same folder as the manage.py file. We will use the Django admin command to start our app. The name of our app is called blog. This creates a folder called blog with the project root and the required files for the app to function. We will take a look at each of these files for the duration of the course, but first we want to be looking in the models.py file. By default, the file looks like this. The first statement is an import statement which imports the required module inside our code. A model is a representation of a database table, and it can be declared as a Python class that inherits from the models.model class. Here we are telling Django to create a database table called blog post, which will have the fields title, author, and body. These are the minimal requirements for a blog post. If you take a closer look, we are also telling Django to make this a character field, which will have a maximum length of 240 characters. Similarly, the author field is also a character field with a max length of 240 characters, but it has the DB index flag set on it. This marks it as an index in the database table. This is useful for indexing the database, and it helps in efficient queries. The final field in this model is the body, which is a text field and contains the text of the blog post. However, this might not be enough, and we will need 3 additional fields, first of which is a published field, which is a Boolean field. The default is set to false, which means when a new entry is created, by default the value of published field would be false. Next we have the created at field, which is a datetime field. This has a flag AutoNowAdd and is set to true. This tells Django that when a new entry is created in this table, the value of this field will be set to the current time. Similarly, we have the updated at field, which is also a datetime field but has the flag AutoNow set to true. This tells Django that each time an entry is edited, it will update the value of this field to that current time for the corresponding entry. This means we, the user, do not have to worry about managing date timestamps at all, as Django can take care of updating them as and when required. Now that we have a model defined, we want to register this app with Django. To do this, we will visit the settings.py file. If you recall the information from the previous section, this is located under the website folder and is the same file as which contains the database settings. In this file, we will navigate to the list called installed apps. This is a list of default apps installed by Django that are useful for the project. We will add our app blog at the end of this list, and now Django will be able to identify our app. We will now run this command and tell Django to generate migrations for the model that we've just created. Migrations are Python files that are used by Django to create database tables. As you can see, this has created a new file 001_initial.py. So let's take a look inside this file. This is the auto-generated file which contains a class called migration. If you take a look here, you will notice that this has all the fields that we have defined in our model. In addition to it, there is also a field called ID, which is used as the primary key for a table. This is an auto-incrementing field and is managed by Django. We will now tell Django to apply these migrations, which will create the database tables by running the following command. As you can see, Django has applied some additional migrations. These are the migrations available from the installed apps that we had seen earlier. On top of that, it also applies the migration file of our blog app that we had just generated. So let's take a look inside the database and see what are the tables that have been created. To do this, we'll use this command which connects to the Postgres database. We are inside the Postgres shell and connected to a database. These are all the tables that Django has created for us. And the blog_blog post table is the one that was created as a result of us defining our model and applying the migrations. If you run a select query, this will return empty rows as we have not yet added anything to our database. But you can see all the attributes of our table. We can now use insert queries to create entries in this table, but to do this we will use the Django ORM instead. For this we will use the Django shell, which is used by the following command. The first step is to import the model, and to retrieve all objects of the table we will run blogpost.objects.all. This is equivalent to running the select star query we ran just a while back. Blogpost.objects here is our entry point for interacting with the database table, and we can create a new entry by using blogpost.objects.create. This is like a regular Python function call, and we pass the values to title, author and body to this function call. We will now run the blogpost.objects.all query, which should return our newly created object. This returns a query set object, which is a list of all the objects available. To verify, let's use the DB shell again and look inside this database table. You can see that this entry has been created with an ID 1 with the title first post, which is what we wanted, along with John Doe and the body exactly as we said. If you remember, in our model we set the publish field as a boolean field which defaults to false, along with the created at and the updated at fields, which in this case are just the same. Going forward, we will only use the Django ORM for playing around. So now that we can retrieve all objects in the table, let's try to use a filter query. This command is equivalent of a filter query where we want to get all the objects which has the ID 1, in this case a single object. We should use the get query in queries where we are certain of that the database will contain only one entry. For example, here we know that ID is a unique field and it will only contain one entry. So now we have the result stored in obj. We can inspect this object a bit more. You can see that the type of this object is blog.models.blogpost, and if you try to get the ID of this object, it would be 1. Similarly, the title of this object would be first post and the body would be hello, this is my first post. In the same way, all the other attributes defined in the model can be accessed via this object. Let's create another object so that we can play with the ORM a bit more. Now that we have two objects, let's take a look at some more examples of using filter. For example, if you wanted to get all objects whose ID was less than 10, you would do the following. Here, LTE means less than equal to, and on hitting enter, this should return both the objects. Similarly, you can replace LTE by GTE, and it would return no objects in this case. Here, this is an empty query set. Let's create another blog post object, but this time with a different author. And now we will use the previous filter query, but with an additional argument by passing the name of the author. Here, this query is equivalent to saying, give me all the blog post objects where ID is less than equal to 10 and the author is John Doe. So as you can see, this has returned just two objects and does not return the blog post object created by Alice. We can verify that Alice has their own blog post object by running the following query. And if you ran the following query with the author set to Bob, it would return an empty query set because we have created no blog posts by the author Bob. There are more ways to use the Django ORM, and we'll find out about them as we progress through the course. For now, we come to the end of this video,